This video will give an introduction to logarithmic functions. Since the exponential function f of x equals b to the x is a one-to-one function, meaning that it passes the horizontal line test, it has an inverse. We call this inverse function log base b of x. Now, thinking back to what you learned about inverses, you know that the domain and the range switch. So since the range of an exponential function is greater than 0, so since the range of f of x equals b to the x is 0 to infinity with a parentheses, so 0 to infinity, that tells us that the domain of g of x, or f inverse x, we could say, the domain of f inverse x, which is log base b of x, is going to be 0 to infinity. So think about what that tells you about what numbers you can actually plug into a logarithmic function. That tells us that you can only plug in positive numbers. So we can only plug in positive numbers. We can only plug positive numbers into a logarithm. And we shorten logarithm with a log, so into a log function. So that's really important to know when you're trying to find the domain of your log function, is that you can only plug positive numbers, so strictly greater than 0. Now let's look at how the relationship between the log and the exponential functions can help us. Since the functions are inverses, the statement y equals b to the x is actually another way of saying log base b of y equals x. So the input of the log function is the output of the exponential function. And the input of the exponential function, the exponent, is the output of the log function. This first function, y equals b to the x, is called an exponential equation, and log base b of y equals x is called a logarithmic equation. So for example, if we saw the logarithmic, or if we saw the exponential form, 5 to the third power equals 125, and we wanted to put that in the log form, the base of 5 would be the base of our log, so it would be a subscript. The output, 125, would become the input of the log, and so we would have log base 5 of 125 equals 3. So the exponent becomes the output of the log equation. And the exponential form of log base 100 of 10 equals 1/2 would be 100 to the 1/2 equals 10. So the base of the logarithmic function is the base of the exponential function. The output of the log function is your exponent, and the input of the log function is your output of the exponential function. When no base is indicated for a logarithm, we assume a base of 10. So seeing this log of x, that's the same as saying log base 10 of x. And we actually have a special name for this because log base 10 shows up so much. We call this the common logarithm. So when you see the words common logarithm, they're referring to log of x, which is base 10. If a logarithm is base e, we call it a natural logarithm, and we write it as ln of x. So if you see ln of x, that's the same as saying log base e of x. Okay, now let's do some practice with just switching back and forth between exponential form and logarithmic form. So we have a few practice problems here. We want to write the exponential equation in logarithmic form. So remember, if we have b to the x equals y, that's the exact same thing as saying log base b of y equals x. So the exponent becomes the output of the logarithm. So here we have an exponent of -4, and we know that the exponent is the output of the log function or the log equation. The base is going to tell you what the base of your log is. So the base is going to be 10 here. And then the output of the exponential function, this is going to be the input of the log equation. And so the log equivalent of this is going to be log base 10, because the base is going to remain the same base as my exponential. The output of the exponential equation becomes the input of the log. So log base 10 of 0.0001 equals the exponent of -4. Now remember from the last slide, log base 10, that's the common log, and we usually just write it without a base. And so we would actually write this as log of 0.0001 equals -4. That would be my final answer of the log form of that exponential equation. All right, let's do another practice. So what you want to do is you always want to identify your base, which is the number that's being raised to an exponent. So we have a base of 2/3. The exponent is going to become the output of the log. So this would be the output of the log equation. And then whatever your exponential equals, that will be your input of the log equation. So the output of your exponential becomes the input of the log equation, or we actually sometimes call it the argument of the log. The thing that we plug into the log is called the argument. So we would write this as log. The base is 2/3, so we'll do a subscript 2/3. The output of the exponential becomes the input of the logarithm, so 8/27. And then the exponent is the output of the log function. So we have log base 2/3 of 8/27 equals 3. And again, the input of a log function is called the argument. input of a log function or log equation I'll just go ahead and say log function because we'll be dealing with some logarithms as functions later. So input of a log function is called the argument. So I'll start using that term. All right, so one more example. Identify your base. We have 3x equals 8 to the y. So I have a base of 8. I have an exponent of y. So the exponent becomes the output of the log function. And then the output of the exponential becomes the input of the log function. So this is going to be what we call the argument, the input of the log function. And so in logarithmic form, I'll have log base 8 because the base stays the same of 3x equals the exponent y. So we've rewritten our exponential equations in logarithmic form. All right, now let's go the other way. Let's get some practice. Given the logarithmic form, let's write the exponential form. So we have 3 examples again, and I'm going to write our basic rule up here. If we have b to the x equals y, that's the same as writing log base b of y equals x. So that's the rule that we're using. You should memorize this switch, this formula for switching. And when you take your test, just write it down at the top of your paper before you even start. All right, so the idea is to identify your base first. So here I have a base of 6. Remember that when you have a log function, the output of the log is the exponent of the exponential equation. So here we have an exponent of -2. And the part that is plugged in to the log, remember that's called the argument. The argument of the log or input of the log is the output of the exponential. So if I want to write this in exponential form, I'll have my base of 6. The exponent is the output of the log function, so 6 to the -2 equals whatever is plugged into the log, so 1/36. And that would be the exponential form of that logarithmic equation. All right, let's do another one. Natural log is base e. Anytime you see the ln, that's a base of e. Remember, the output of the log is going to be your exponent. And the input of your log equation is going to be the output of the exponential. It's because the x and y values switch. So your input and output switch because exponential and logarithmic are inverses. So the output of the exponential is going to be 4x in this case. So I have a base of e, an exponent of y, and then an output of 4x. So e to the y equals 4x would be the equivalent exponential form. Okay, and one more, we have log of 10 equals 1. Remember, when there's no base written on the log, that's an implied base 10. This is the common logarithm or common log. And then the output of the log is your exponent. And the input of the log is going to be the output of the exponential. So I'm going to have a base of 10, an exponent of 1, and an output of 10. So that would be the exponential equivalent of log of 10 equals 1. 10 to the 1 equals 10. Okay, we'll get more practice on logarithmic equations in the next video.